Good morning, children. Today we are going to study about lines and angles. We started with the Euclid geometry, that is the first geometry chapter for this year, and the continuation only. Some applications, axioms, postulates all are coming here only. And this particular academic year, there is no relation from this chapter, lines and angles. So that means all the exercise, all the theorems, everything you have to study. And as you heard first only that 9th class syllabus is majority covered with the geometry only. So it is little bit difficult for your level. But this chapter is okay for you, so you can learn very well and concentrate more on the steps what I am telling, how to write the theorem, how to write the proof, everything I'll explain in the class. Go through that one detail because it's the first time you are learning like this. Many theorems are coming this particular class. So first we learn about the basic terms and definitions. The first one is line. You have already studied about this definitions in the lower classes. Just to recap only, we are doing the first part. Line means it is joined with a set of points and it can be extended indefinitely on both the sides. With the arrow itself, you know that it can be extended both the sides indefinitely, and usually it is denoted by the letter, small letter only. So here I am marking with the L only. What is meant by line? Line is joined with a set of points and both the directions, which can be extended both the directions indefinitely, and it is denoted by the line L. So what is line? A line is joined by set of points and it can be extended both the sides indefinitely. It is denoted by L or M, anything but small letter only we should use. Now what is the next part? A line segment. Line segment means it is a part of line, right? It is a part of line. From this we are taking a small part. It is usually represented by like this only, with a 2 dot, means fixed points. And if I am writing this one as a line segment, means we can measure and write. That means a fixed line segment we can measure and write. So usually denoted by AB, means in if you want to say it is a BA, then both the way it is right only. So a line segment means a line segment has fixed length, right? Fixed length. It has 2 endpoints. Within that endpoints only its length. Now what I told here, it is the part of a line. It is a part of line. Usually how we will write? Usually we write as AB or BA. Both way it is correct only, and it is specifically we will put 2 dots showing that it is the line segment, right? From the line only we are taking. We have already learned all these things, so just explanation only. One more thing it is there. What is that one? Ray. That is also part of line only it is, and ray usually have starting point and one side we can extend indefinitely. So A and B means we should say that ray AB. Now what is that? It is also part of line and it has a starting point. Initial point is there, then that only we should say first. So it has a one fixed point. A ray has one fixed point, that is the initial point, we can say. Initial point, and it can be extended in one direction indefinitely. Ray AB means it should be like this. We cannot write that ray AB, we cannot write that BA. It is wrong because the starting point is A only. So we should write A as the starting point. So once again, line segment, ray means what? Line means both the side we can extend. Line segment means part of a line. It has a fixed length and fixed 2 points. And ray means it is extended only one side. If you are drawing the diagram like this, see, if you are drawing the diagram like this and you are writing BA, this will be ray BA because the starting point is B only, right? Now it is also extended one direction only, where line can be extended both the directions. Line is denoted by the letter A, line segment is denoted by like this, and ray is denoted by like this. After studying ray, you have to study about angle. It is formed when two rays originate from the same endpoints. See that one, OA, OB are the two rays and originating at O only, and they are forming an angle AOB. The middle letter, that is vertex O, is normally denoted by showing the angle. Angle AOB we can tell this, or we can say that just angle O, because the middle letter only shows the angle. Now what are the arms here? OA and OB are the arms of the angle. Ray OA, ray OB are called the arms that only originating together or meeting together at the point O and making the angle there. So this point is called as a vertex. So if any other angle, if you are taking, suppose I am taking the angle like this, and here I am writing that P, Q, R. So which are the arms here? QR, ray QR and ray QP are the arms, and the Q is the vertex. So what is the definition of an angle? Angle is formed when two rays originate from the same endpoints. So here what we have to say, angle AOB is the diagram, and where OA, OB, ray OA, ray OB are called arms of the angle, and vertex O is called the vertex of the angle. Now different types of angles, what we have studied in the lower class, just recap only. So with the diagram itself you can understand very clearly. First one is acute angle. The value is varies between 0 to 90, that means more than 0 and less than 90 degree. Now the second angle is when the right angle, that is the angle measure is equal to 90 degree. Now see, you can see the diagram. And obtuse angle, when the angle measure is more than 90 but less than 180 degree. Now what is the next angle? Straight angle. Straight angle means what is the value? 180 degree. The diagram will be a straight line only. We have to mark the angle like this. So straight angle, when the measurement is equal to, angle measurement is equal to 180 degree. Now reflex angle, it is varies between 180 degree and a 360 degree. That means more than 180 and less than 360 degree. Complete angle means 360 degree, the value equal to 360 degree. Acute angle, I'll explain once again what are the different types of the angles. Acute angle, right angle, obtuse angle, straight angle, reflex angle and complete angle. The acute, right, obtuse and straight angle, there is no confusion for the children, but reflex there may be some doubt. So suppose this angle shows that it is 40 degree. Okay, so how we will calculate the remaining angles? 360 minus 40. That will be the reflex angle, right? 360 minus 40. What is the answer? 320. We will get, suppose if you are having 60 degree here, it may not look like 60 degree. If the angle measurement is 60, so reflex of the 60 means 300 degree. From the 360, we should subtract this angle. Then we can calculate the remaining value, that is 300 degree, right? So like that we can calculate the reflex angle. And the complete angle, we know that it is initial line and the final terminated line, and that is ending line, will become both the same only. So it will be a complete angle. So single dot only it is actually the initial ray and the final ray will be coincide together. So the total angle is equal to 360 degree. I repeat once again, angle measurement varies between more than 0 and less than 90, then the angle is called acute. When the value of the angle equal to 90 degree, then it is called a right angle. When it is more than 90 and less than 180, it is called obtuse angle. When the value of the angle equal to 180 degree, it is called a straight angle. Now reflex angle varies between 180 and 360, and the complete angle is called a 360 degree. Complementary and supplementary angles. The sum of two angles is 90 degree, then they are called as a complementary angles, and the two angles sum is 180 degree, then it is called as supplementary angles. That means 60 and 30 are both are complement to each other. 60 degree and 30 degree. One first pair we can say both are complement to each other. That means complement of 45. What we can say, complementary angle of 45 equal to 45 only, because 45 plus 45 it is equal to 90. 60 plus 30 it is equal to 90. Now my question is, what is the complementary angle of 20? It is equal to 70, right? Like that we can write the supplementary angles. Supplementary angles, if suppose I am writing supplementary angle of 60 degree. What is the answer? You can tell me. Supplementary angle of 60 degree equal to 120, right? Because 120 plus 60 it is equal to 180 degree. Now if we have taken 90 plus 90, what is the sum? 180 degree. So both are complement to each other only. Suppose I am taking 110 plus 70. What is the sum? 180 degree. So what we can say, 110 and 70 are supplement to each other. Supplementary angle of each other, right? So when the sum equal to 90, both are complement to each other. When the sum is equal to 180, both are supplementary of the each other. Adjacent angles. Two angles are said to be adjacent if they have a common arm, if they have a common vertex, and two angles are lying on either side of the common arm. Let us see this example, means a diagram. We have marked here, see, COA is the bigger angle, and we have joined one more ray here, that is OB. Now by the definitions of two adjacent angles, angle 1 and 2 are called adjacent angles only. What is the reason that one? First definition is that they have a common arm. See, the first angle is I have taken as angle AOB, right? Angle AOB is the first angle, right? Now what is the second angle? Angle 2 is equal to angle BOC. Now by the definition of this one, they have a common arm, means I can write here ray OB. Okay, what is the common vertex? Vertex is O. Now two angles that is lying on either side of the common arm. That means if common arm is decided, one is this side we have taken, means one is the below the line we have to get it. Like that we have to get the both the sides. Or we can say that non-common arms lying on the either sides of the common arm only. Then only we are getting this one. So these two sides, OC is above the line and OA is below the common arm. Then only the conditions are satisfied. Then we can say that these two angles are called adjacent angles. Now see the definitions of this one. See the examples. I have given 3 examples. Let us see the diagrams. I have marked angle 1 here and angle 2 is just. So angle 1 is which angle? XOZ. And angle 2 equal to XOY. Here common vertex is satisfied. O is the common vertex, right? Now angle 1 is taken as a angle AXOZ. So XOZ, XOY, you can see that OX is the common ray. Which is the common ray? OX is the common ray. But these two angles are lying above OX only. So we cannot say that angle 1 and 2 are the adjacent angles. Now similarly here we can say what? Angle 1 and angle 2 we have taken. So here I'll mark O. This side A, B, C and D. Which is the angle? First one, angle 1 equal to AOD, angle 2 equal to BOC. Only which angle is satisfied here? Which property is satisfied? Common arm is satisfied. Now we are not getting any common ray. OA, OD are the ray for this one. OB and OC are the ray for the second angle. So there is no common arm. So that is not satisfied. Only the vertex is satisfied. Second point is satisfied. Now so these two are not adjacent. Now what about this one? Angle 1 and angle 2. Angle 1 means angle POQ. Angle 2 means angle, I'll write it T, angle RTQ. Right? Now which is the common vertex? No common vertex is there. Angle 1 is formed with the vertex O, angle RTQ is formed with the vertex T. So second property is not satisfied. There is no common vertex. Now arms for POQ, OP as well as OQ is coming. Right? But for angle 2, what is the arms here? Angle TR and TQ. So that is also different. So any one of the condition is not satisfied, then we can say that that pair is not adjacent angle. So here you understood this one. What are the point A? It should have a common arm. Which is the common arm? OB. Which is the common vertex? Vertex is O. Now non-common arms, that is the other angles, it is formed on the either side of the common arm. So one should be the common arm, means one is above the line, one is the below the line we are getting. So these are the definitions of the adjacent angle, or we can say the angles should not overlap. The angles should not overlap here. So these three conditions should satisfy, then only the angles are said to be adjacent angles. Next is linear pair. Linear pair means it should be adjacent angles first. A pair of adjacent angles whose non-common arms forms a line. Common arm is there, that is OC, and non-common arms means which one? OA and OB, that forms a line. Line means a straight angle. So the sum of these adjacent angle equal to 180 degree in the case of a linear pair. So linear pair means what is the first condition? It should be adjacent angles, and the adjacent angles sum is equal to 180 degree, or what we can say, non-common arms equal to it forms a line there. If it is forms a straight line, means then the angle will be naturally it is equal to 180 degree. This we learn later the axiom as axioms. We will have the statement also, that we will study later. Now what is the vertically opposite angles? Two lines AB and CD, they intersect each other at one point. Intersecting lines we are taken AB and CD, then it is intersected to O. Then how many angles are formed? 4 angles are formed. 1, 2, 3 and 4. These vertically opposite angles are equal. So we will prove as a theorem later. So what is the meaning of that one? Vertically opposite angles. 1 means opposite angle is 3. So vertically opposite, 1 equal to 3 as well as 2 equal to 4. So AB and CD are the two lines intersect at O. Then we are getting 4 angles. In this pair of angles are equal. Which are they? Opposite angles. Angle 1 equal to angle 3 and angle 2 equal to angle 4. These angles are called vertically opposite angle and they are equal. Intersecting lines and non-intersecting lines. Intersecting lines means what I should say, they will have a common point. A, B and C, D are the two lines. They are meeting at O, means the intersecting point is O. So they are having a common point. Whereas non-intersecting lines will not have any common point. And moreover, we can say that non-intersecting lines are called parallel lines. And the distance between the non-intersecting lines, so if they are parallel, then the distance between them is also same. They don't have any common point. Intersecting line have one common point and it is a line. Both the case it's lines only, whether it is intersecting or non-intersecting. So we can extend both the directions indefinitely, and intersecting lines will have a common point, whereas non-intersecting line is not have a common point. They will never intersect. That means the lines are parallel. And also what we can say, that the distance between the parallel line is always remains the same at any point. Next is linear pair axiom. We have seen what is a linear pair. Now this year we have to study it is an axiom only. Last chapter, that is Euclid geometry, you have seen that what is meant by an axiom. Axiom is an universal truth and which can be accepted without proof only. So the first statement says that if a ray stands on the line, then sum of two adjacent angles so formed is 180 degree. So ray stands on line and sum of two adjacent angles is equal to 180 degree. That means it should be adjacent angle and the sum is equal to 180 degree for a linear pair. In converse way, we are starting in the last part. If the sum of two adjacent angle is 180 degree, then a ray stands on a line, or we can say non-common arms form a line. Now here you see, here also I got a pair of adjacent angles 60 and 70, but the sum is equal to 130 only. So this is not an example for which one? Linear pair axiom, right? Now when we have this should cancel, this is not an example for linear pair axiom. Now see this one, 70 and 110, then sum is equal to 180 degree, and moreover these two are adjacent angle only. And what is the first statement? Says that if a ray stands on a line, so I'll write here O and A B. So AOB is the line. If a ray stands on a line, I'll explain each word. A ray stands on a line means ray is OC, stands on the line AOB. Now then sum of two adjacent angle is formed is 180 degree. Then if it is a linear pair, the adjacent angles sum is equal to 180 degree. Now reverse way, sum of two adjacent angle is 180 degree. That means 110 plus 70 sum is equal to 180 degree. Then the ray stands on the line, or we can say non-common arms, that is OA and OB forms a line. Clear this one? So this together, this statement together are called a linear pair axioms. Which are called a linear pair axiom means we should, meaning that both the statements should be included. Now you can write as a reason when you are applying in the question, you just write linear pair axiom only because you have studied. Since it is axiom, no proof is required. Once again, what is the statement says? You have to learn this one clearly. If a ray stands on a line, that means OC stands on AOB. Sum of two adjacent angles so formed is 180 degree. Which are they? AOC and BOC. Sum is equal to 180 degree. Now the converse, if the sum of two adjacent angle is 180 degree, that means two angles sum is 180 degree, then the ray, that is OC, stands on the line. Which is the line? AOB. Or what we can say that non-common arms OA and OB forms a line. So this is one of the important axiom for this chapter. Both the statements you have learned it thoroughly. When we are doing the applications, we can just write the linear pair axiom only. State linear pair axiom can be asked, so the statement should be learned. So today's class I am winding up. Just we have gone through the definitions, terms, definitions, basic terms and definitions, and whatever the topics related. Just we started the chapter only, and it is a geometry only, little bit difficult to remember. So write and learn, that is only the suggestion I can give. So today's class I am winding up. Thank you.